All right, so 10.1 is 52.4 psi, 10.2 is 21.6 or 21.7 psi, 10.3 is 25.4 feet, and then 10.4, what we got for that is we've got the velocity is 17.94, and the flow rate is 0.391 cubic feet per second.
On 0.3, I'm sorry?
Yeah.
Can we go over that, I guess?
Yeah.
52 psi and then defeat, and 41 psi and defeat, and subtract.
Oh, I used the chart that we were.
Last times I've had the 2.3.
Table.
Oh, yeah, 10.3, what you're doing, you've got enough information to fill in both sides of that chart. So what you've got there, you got 52 psi, and that translates to 120.1 feet. So on 10.3, what you'd want to do is get those pressures converted into feet of energy. Okay, and there's different ways to do this, I guess. So the way I did it was 52.4 psi times 2.31 feet per psi, and that comes out to be 120.1 feet. And you can do the same thing on the 41, and you'll get 94.7 feet.
Where did you get the 0.4 on the 52.4 psi?
Oh, yeah, my bad. It's just 52.
Okay, this one I would just.
Yeah, 52. I don't know where I came up with that. I think the answer is what it is.
Yeah, 25.41 probably where.
Yeah. Okay, so we got that. So then, if you want to make a chart out of this, you'll have elevation, pressure head, velocity head, and then total. So what we got for both elevations, we got 0. That's A and B. For the pressure heads, we've got these numbers shown.
Oh, that's right.
Yeah. Velocity head you can ignore because it's going to be the same at both locations. It's the same size of pipe. So the head loss is the difference between these two. So if you take the 120.1 and take away the 94.7, you'll get the head loss. And that is 25.4.
Can't you just do 92 psi minus 41 psi?
Yeah. Quicker way to do it is just to take 52 minus 41. So you got 52 psi minus 41, you get 11 psi drop, and then convert that to feet. And that'll get you 25.4. That's a quick way to do it, because to do it that way, you have to recognize that the pipe's flat. There's no elevation change, and that you're ignoring velocity head. Okay. So there's different ways to do it, as usual. Everybody okay with that one? Okay, next one. You okay with that? You're going to have to do a chart. You end up with 5 feet of energy at B, and that's all going into the velocity. Okay? So you solve for velocity by using velocity head on this next one. So I'll just call it A and B. Elevation, pressure head, velocity head, total. So here you've got 150. No pressure at the top of the reservoir, no velocity head up there. So that's 150. And then you got 145 feet of head loss. So you end up with 5 feet of energy at B. no elevation, no pressure, so it all goes into velocity. So 5 is equal to v squared over 64.4, which is velocity head, okay? And from there, you just have to solve for v. Multiply both sides by 64.4, you get v squared is 322. Take the square root, you'll get the velocity. So that's how that goes. And then if you want to find the flow rate, you take the velocity times the area, and that'll come out to be 0.391 cubic feet per second, which is also 126 gallons per minute if you want to figure that out too.
Equations will look 2v instead of v2. It's 2 times the velocity, not the velocity times itself.
No, that's v squared. That's part of the equation. If this one right here, you mean?
Yeah, when you get 64.4, it's not v squared.
Yeah, it's v squared over 2 times gravity. Yeah, wait, so gravity's 32.2. So it is v squared on the top. Okay, you doing all right with that? Right, next one here, find the velocity and pressure at B. This one takes a little bit of messing around with it. You know, what you're gonna, again, you want to get a table going with this. That's how I would approach it anyway. This is 27.72 feet. That's the pressure head there. You want to get the area on both sides. So this first area is 0.0491 square feet, and the second area is 0.00545 square feet. All right, and then you want to take 80 gallons per minute and convert it. And when you do that, you'll get 0.178 cubic feet per second. You just have to do the unit conversions there. You've got a couple conversions to do. All right, and then you want the velocity at A, which is Q over A. And that'll be 3.63 feet per second. And then you want the velocity head at A, which is V squared over 64.4. And that comes out to be 0.205. And I call it 0.21, I guess. Or 20. Well, it rounds out to 20, so we'll call it 20. All right, and then you want to do the same thing at B. So VB is equal to Q over A, and that'll come out to be 32.7 feet per second. and then the velocity head at V will be V squared over 64.4, and that comes out to be a lot higher. That's 16.60 feet. So you just want to get all that stuff figured out, and then you can put it into a table. So there's no elevation. We got the pressure head there. 27.72, and it's the unknown there. And then the velocity head, 0.2, and then the total. So 27.92. No head loss, so it's 27.92. This is 16.6. So the velocity head comes out to be 11.32. And so 11.32 feet times 0.433 PSI per foot, and that'll get you the PSI, and that's 4.90. Doing all right with that?
What are you using for the velocity head for V, for V?
32.7. So that's the velocity at B.
Of a 1-inch pipe, yeah, right.
Yeah, Q over A. Doing all right? All right, and then the last two are hydraulic grade line problems. So what you're going to do, you're just going to take the pressures and convert them into feet of elevation. So for instance, you'll take 13 psi times 2.31 feet per psi and convert that over, and that comes out to be 30 feet. So from there you go from 13 up to 30 and put a dot there. That's an elevation point, and then connect the dots. Do the same thing for the other two, and you'll get the hydraulic grade line. You doing all right with that? Okay. All right, so that's the stuff that's due Wednesday. Okay. All right, we still got a bit of stuff here with head loss to cover. Anybody not here on Friday and wants that handout that I gave? I put a little note out that I had, it was not mine, but so we went through a bunch of different situations with these different pipes and different ways of figuring out pipes pressure, which is probably the most basic thing to find, but then we also looked at flow and pipe sizing, okay? And we did that for C100 and also C not equal to 100. So are we okay with that stuff? You got any questions on that? So not only do you have head loss in a pipe, a long run of pipe, but you also have head loss when you force water through fittings. You know, you're seeing it there if you come up around that bend there. That's going to cause head loss. Here you see a number of junctions and bends. Anytime water flows through something like that, there will be head loss. All right, and so that's something to, to understand that head loss occurs when you make the flow change direction or you constrict it or do something like that. So we want to have a way to account for that, okay? And those are called minor losses, even though they sometimes can be quite major, you might say. So minor losses occur when water flows through fittings. I'm on page 122. All right, so the way of figuring out minor losses, there's a couple different ways. We'll do the one that's based on the Hayes and Williams approach. And what you do there is you convert the fitting into what they call an equivalent length of pipe. So essentially what you're going to say there is this bend in the pipe has the same head loss as 30 feet of pipe, and then you find the head loss for 30 feet of pipe. Okay, that's basically how this works. So you just convert the pipe into an equivalent length. Convert the fitting into an equivalent length of pipe, and then find the head loss for that length of pipe. That's how this method works. All right, and then on the next page there, I've got a number of different fittings. and there's a method to convert them. And that's on page 123. You know, there's some outlets and inlets there that we consider. There's also some T's. When you're looking at T's, you have to consider which branch of the T the water's flowing through. So that's another aspect of this, okay, that you need to consider. So what you have there is an L over D value, and what the L over D is length over diameter. That's what that means. So that's an L over D value. So let's have a look at an example of how you'd use this. So let's say we've got the water flowing through a little system like this, and we want to find the head loss that occurs. Okay, we're going to assume everything is unlined cast iron, so that means that C is 100. Now, some of the stuff on there you've got, it's just 8 feet and 10 feet of pipe, so that's easy enough. But you've also got an ordinary outlet, which is just a flush pipe on the bottom of a tank, kind of like what you got on your bathtub. And then we've got a 90-degree standard elbow, so just a regular elbow turning a right angle. All right, so let's see what the values for these things are going to be. So what you do there, you'd go to page 123 and you'd look at an elbow, 90-degree standard. Looks like L over D is 64. And then we got an ordinary outlet. And let's see, outlets, ordinary, let's see, outlet, ordinary outlet from flush pipe to reservoir, L over D is 20. Okay. So I'm just on that chart on page 123, finding those L over D values. All right, now we got a 6-inch pipe here. Okay, so 6-inch pipe. Yeah, so.
Where's the 6-inch on there? LSE, or am I looking at the wrong thing?
That's just right up here.
Oh,
It's in the written problem
yeah.
statement. Yeah. Written problem statement there. Now, the one thing you want to do is get the diameter into feet. Okay. So if L over D is 20, what that means is the equivalent length, using a little bit of algebra there, would be 20 times D. And similarly, the equivalent length here would be 64 times D. Okay, so the equivalent length here would just be 20 times 0.5. So L equivalent for the outlet would be 10, and that's feet. And then the equivalent length for the elbow would be 64 times 0.5, so the equivalent length there would be 32 feet. So what you do, you just find the equivalent length of the fittings as though they're pipes. So that says that when the water flows through an ordinary outlet, it has the same head loss as if it was flowing through 10 feet of 6-inch pipe. And when the water flows around that bend, that would give it the same head loss as 32 feet of pipe. That's basically it, okay? Okay, so this is 20 times 0.5 feet, which is 10 feet. And this one is 32 times 0.5 feet, and that's 16 feet. Okay, so for the whole system then, you got the 10 for the outlet, plus the 8 feet of pipe, plus 16 for the elbow, and then plus, I think it's 10 more feet of pipe. So you just add everything up. So 20 and 24 are 44 feet. So that system has the same head loss as 44 feet of pipe. Oops, I screwed up. That's not 2016. It's 64. It's 32 here. I've got a typo right there. Sorry. There we go. Okay. And then you can find the head loss per 100 for 240 gallons per minute, 6-inch pipe, C100. Just go to page 108 for that. So 240 gallons per minute, 6-inch pipe. Not much. So we got just not much, 0.51 feet. So that's the approach you take on those. You just convert the fittings into pipe by using that L/D ratio. So why don't you have a look at that on the homework, 12.1. It's almost towards the back of the book there. It's got a couple lengths of pipe and a gate valve, half open gate valve.
Twelve point
12.1. Yeah. Looks like that. There's two problems on the page, 12.1 and 12.2. The one on the top. Why don't you work that out using this method? Should get something on the order of about 3.665. So have a look at that chart, you got a half open gate valve, have a look at the chart to see what the L over D for that would be. About 3.65, I think is what that one comes out to be. So this, find that L over D value for the gate valve. Should be 180, I think, for L over D off the chart. And then remember, get your pipe into feet. Get that L over D. Yeah, right. Yeah, right. Times 180. Yeah, yeah. Oh, it's not very. Working or something.
Yeah.
You right? So the equivalent length of the gate valve is 120 feet. So it has the same head loss as 120 feet of pipe. Okay. You all get to that okay? And then just add any other lengths of pipe and then find the head loss to that system.
Don't you wanna get those 18 and 12? Oh, exactly.
Hmm. Okay, so you want to find that L over D value, and then to find L, you multiply whatever your D is. Remember to get that into feet for D, because pipe sizes are given in inches, so remember to get that into feet, and that'll get you your equivalent length. Then I just add that to the pipe lengths in the system and get the total. Multiply that by the head loss per 100. Okay. Doing all right with that?
So where does the 1.5 come from?
The 1.5 comes from the 150. Because we got 150 feet, that's 1.5 100-foot lengths.
Okay.
I multiply it there. So instead of going 2.43 over 100, I just convert the pipe lengths into 100-foot lengths. Okay. Other questions? Yeah.
Just one question, just for rounding and stuff like that, because I got 3.4. Is that too different of a number for that?
It's getting there. I mean,
Okay.
do you know why that happened? Or anything?
Yeah, because I just did 0.66 instead of 0.667 for the.
Yeah, that's well did it. It seems to me maybe something else happened.
Because when I did that, that's using the most I got for that.
Yeah.
And then, so I mean, that one's significantly off from the 150 that you had, so.
Oh, it's 30 though. That should have been
Yeah.
118. That should have been 40. Because 18 and 12 is 30. Oh, that's LT. No, that's not. Where did this come from? Oh, but no, you just use 12 and 18 straight up.
Oh. Gotcha, okay,
That's all.
okay.
You know, I mean, don't overcome.
Right,
Understand that.
okay.
Yeah.
All right. Okay, so that homework's due Wednesday. Okay, we'll cover some other stuff on Wednesday too, and then we've got that other homework that's coming due Monday, okay, which is the chapter 11, I think. Yeah, chapter 11 stuff.
And you want this back for sure Friday?
That's part of the chapter 11 homework. So that can come back Monday, because I know a lot of you aren't here on Friday.
Well, this-
That's the one you just handed out, right?
The one I just handed out is part of the chapter 11 homework. So it's due on Monday of next week.
Okay.
Right? Yeah, that's what that is. It just replaces some of the problems in the back of chapter 11, that's all it is. Okay. Are we okay with that? Good to go? See y'all Wednesday.